This is a solid you can hold in the palm of your hand, and it's 99.8% nothing but air. It's called aerogel, and by weight, it's one of the emptiest things human beings have ever made. Take any solid you know, delete 99.8% of it, keep the exact shape, and what's left still stands on its own. That's aerogel. This isn't a trick of the light. Aerogel holds 15 separate entries in the Guinness Book of World Records, including the lowest density solid ever measured. Something this empty should crumble like ash. Instead, you can aim a blowtorch at one side and press your bare hand flat against the other. NASA once flung a slab of it into the tail of a comet to catch dust moving faster than a rifle bullet, and it worked. But the strangest part isn't how empty it is. It's that we've now built a version lighter than the air you're breathing, and the whole story begins with a bet over a jar of jelly. In 1931, as the story is often told, a chemist named Samuel Kistler made himself a strange little wager. Could you take the jelly sitting in a jar and pull out every drop of its liquid without the jelly shrinking or caving in on itself? A jelly is mostly liquid, held inside a flimsy solid web. Dry it the ordinary way, and surface tension drags that web inward until it collapses, a grape crumpling into a raisin. Kistler's move was to heat the liquid under pressure until it was neither liquid nor gas, but a strange in-between state called a supercritical fluid. In that state, there's no surface tension left to pull. The liquid simply slips away as the pressure drops, and the solid web stays standing. Now filled with nothing but air, he won the bet. What he'd made, he named an aerogel, a gel with its liquid quietly swapped out for gas. He had, in a sense, made a piece of solid nothing, with no clue it would one day fly to a comet and keep robots alive on another planet. It looked like nothing else on Earth. People reached for the only words that seemed to fit: frozen smoke. Hold a piece up to the light, and your eyes start arguing with your hand. It glows a faint blue, like a curl of smoke frozen in midair, which is exactly why it's nicknamed frozen smoke, solid smoke, even captured cloud. But that blue is not a dye. There is no pigment in it anywhere. Aerogel is spun from silica, the same material as glass and sand, into a skeleton of strands thousands of times thinner than a single human hair. Those strands are so fine that they scatter the short, blue wavelengths of light more than any other. The very same reason the sky over your head is blue. So a lump of aerogel is quietly doing what the entire daytime sky does. In a piece the size of a sugar cube, pick it up, and it feels like almost nothing at all. Warm, dry, and impossibly light, like handling a solid piece of air. Rest it on a bed of flower petals, and the petals barely bend beneath its weight, which raises an obvious question. If it's basically air trapped in a thin glass web, why doesn't it melt the second you bring fire near it? Here's the demonstration that made aerogel famous. You lay a thin tile of it flat on your open palm. Then someone points a blowtorch straight down at the top of it. The flame is hot enough to melt aluminum. The underside, resting against your skin, stays cool enough to leave your hand exactly where it is. The answer is all that emptiness again. Heat crawls through a solid by rattling from one atom to the next. And in aerogel, there are barely any atoms in the way. It can't ride the air either, because the air inside is locked in pockets far too small to swirl around and carry heat. That makes aerogel one of the finest insulators ever measured, beating a thick stack of fiberglass in a slice just a few millimeters thick. To match it with ordinary foam, you'd need a slab several times thicker, which is how a whisper of aerogel can do the job of a heavy winter coat. It isn't fireproof forever. Push past about 1200 degrees Celsius and the delicate silica skeleton finally slumps and collapses. The real trick is that it stalls the heat long enough to matter. which is why you'll find it wrapped around oil pipelines, built into spacesuits, and sewn into jackets thin enough to move in, yet warm enough for Everest. But the boldest thing anyone ever tried with aerogel wasn't down here keeping us warm. It was hundreds of millions of miles away, chasing a comet. In 1999, NASA launched a spacecraft named Stardust on a genuinely bizarre errand. Its target was a comet called Wild 2, and the plan was to fly straight through the dust streaming off it and grab a handful. Comets are frozen leftovers from the birth of the solar system, so those specks of dust are a 4.5 billion-year-old time capsule. But there's a catch. Stardust would meet that dust at around 6 kilometers every second, roughly 6 times faster than a rifle bullet. At that speed, catching a grain with anything solid would vaporize it on impact. You'd destroy the very thing you crossed the solar system to collect. So the engineers built a tray shaped like a tennis racket and packed it with aerogel, the softest, emptiest solid they had. Each speck of comet dust punched in and braked gently over a long distance, carving a carrot-shaped tunnel hundreds of times its own length before stopping, intact. In 2006, a capsule parachuted into the Utah desert carrying the first pieces of a comet ever brought back to Earth, cradled the whole way home in frozen smoke. Volunteers around the world then combed through scans of that aerogel, hunting for microscopic tracks left by grains older than the sun. That same gift for beating the cold had already saved a rover. NASA wrapped aerogel around little Sojourner to keep its electronics alive through the deep freeze of a Martian night. Mars nights plunge far below zero, cold enough to kill unprotected circuitry, and a thin aerogel blanket was enough to hold the day's warmth inside. And that's when researchers started chasing a bigger prize. Not how empty they could make it, but how light. Light enough to lose a race against air itself. Kistler's original aerogel was already absurdly light, but it turned out to be only the starting line of a race to the bottom. Chemists tore out the silica skeleton and rebuilt it from pure carbon, and then from graphene, sheets of carbon exactly 1 atom thick. Graphene is the strongest material we know of, and yet you can arrange it into something so sparse it's very nearly vacuum. Line the lightest solids up by density, and the numbers stop feeling real. Cork, then silica aerogel, then metal microlattices, then a ghostly foam called aerographite. And at the very bottom sits aerographene, a graphene aerogel weighing about 0.16 milligrams per cubic centimeter. Here's the part that breaks your brain. Dry air weighs more than that. The solid skeleton of this material is literally lighter than the air around it. Set a block of it on a dandelion, and the seeds don't even scatter. It just rests there, like a shadow that forgot to leave. It doesn't drift up into the sky only because its pores are packed with that heavier air. Pump the air out, and there's almost nothing left to weigh. Materials this light aren't just curiosities either. They're being tested to mop up oil spills, store energy, and insulate the spacecraft of the future. From a bet over a jar of jelly to the lightest solids ever built, every one of them is the same quiet trick, a rigid web wrapped around an enormous amount of nothing. A solid that's almost entirely air, light enough to rest on a dandelion, tough enough to catch a comet, cool enough to cup in a bare hand against a flame. You really can hold it in the palm of your hand and hold, very nearly, nothing at all.